Hello. In this lesson, I will explain to you how to rig such a horse using M-Gear. I recommend that you first check the lesson on the anthropomorphic character rig, where we talked about the M-Gear basics. Because in this tutorial, I will skip what was detailed earlier so as not to repeat myself. I've uploaded the model and assigned the basic materials according to the concept so that the character is better perceived. The model consists of the following objects: a mane, a tail. The bracelet around the neck will be created and synchronized in Houdini, so now they are presented in a simplified form. I will pay minimal attention to their deformations and behavior. Well, let's just start creating the rig. I'll open the Guide Manager and create the first component. Control 01. This will be the rig common controller. I will name it Local and leave the guide at the center of the coordinate system. Now I will create a common controller for the body. This will also be the Control 01 component. I'll rename it to Body and place it in the center of the body. Now, as a child component, I'll add the spine. Let this be Spine IK01 component. And I'll position the guide so that the root is at the base of the pelvis, and the effector is closer to the edge of the chest. Something like this. I'll add the back leg as a child component of the spine root so that it follows the pelvic transformation. I will be using the Leg 3 JNT01 component. It can be seen that it is intended for the leg and consists of 3 bones. Just the thing we need for the hind limb. I'll rename the component as Leg Back, change the side to left, and align the joints with the model. At the same time, the penultimate joint will be placed just above the hoof in accordance with the anatomy of the horse. All joints of this component must lie in the same plane and therefore cannot be shifted to the sides. Therefore, I've unfolded the uppermost guide a little to better align the knee. I'll open the back leg properties. In the Component Settings tab, I'll add the objects to the IK ref field so that I can switch parents for the leg controllers. The IK controller must follow the local common controller. I'll add it to this list and also will add body just in case. Then I'll copy these settings for the up vector. Now I'll add a component for the hoof. This will be the foot BK01 component. I'll create it as a child component of the leg back L0 foot object. I will reduce the number of sections to 2 and change the directions to Y-, so that the chain is built downwards. I'll change the name to foot back and make sure the connector attribute is changed to leg 3 JNT01. Because I used this component for the back leg, and I'll position the guides according to the geometry. Like this. Now I'll add the shoulder blade as a child component of the spine C0F object, so that the shoulder blade inherits the chest transformations. This will be the simple Control 01 component. I'll rename it to Shoulder, change the side to left. I will need a joint in this case, so I enabled the joint option and disabled world space orientation align, so that the controller is oriented the same way as the guide. After that, I'll position and rotate the guide in accordance with the shoulder blade. Something like this. Now I'll add the front leg as a child component of the shoulder blade. I'm simplifying the real anatomy of a horse a little. I will be using the component leg2JNT01, which creates a leg consisting of 2 bones. I'll rename the component to leg front and position the guides according to the geometry, while leaving a slight angle in the second joint for proper operation of the inverse kinematic solver. Similar to the back leg, I will add objects to the fields of the IK reference array to be able to switch the parents of the leg controllers. These will also be local and body. For the front hoof, I will copy the component of the back leg, select L0 root of this component, foot back L0 root, and click the duplicate button. After that, I'll drag the copied component to the guide leg front L0 ankle of the front leg. I'll align it with the geometry, rename it to foot front, change the index to 0, and change the connector to leg2JNT01, since that's the component I used for the front leg. I'll add the neck as a child component of spine C0F guide. I will be using the neck IK01 component. I'll align it with the geometry, position the root somewhere in the center of the neck, at its base, and place the neck C0 neck guide at the base of the head. And here I will adjust the curvature of the neck. I'll enable on the IKCTL World Ori option so that the IK control at the neck is oriented relative to the coordinates. I'll also enable tangent control so that there are additional controllers for tangents. Next, in the IK reference array, I will indicate the objects that the neck and head can follow. Let it be the local common controller of the body and perhaps of the chest. I'll copy these settings for the head. Now I'll add the left ear and create it as a child component of the object neck C0 head. I'll be using the chain spring 01 component in order to automatically get the secondary movements. Let there be 3 sections. I'll change the name, the side to left. Then I will also create a chain in the same way so that the front of the head can be deformed. This should be the spring chain component consisting of 3 sections. For the glasses, I'll probably also create a spring chain consisting of two sections, so that it is more convenient to control the general position of the glasses via the first section and secondary movements via the second one. Now I'll add an eye. I'll create it also as a child component of the head with the neckC0 head object. And this will be the I01 component. I'll change the side to left and align the root with the eye with the center of the eyeball. The eye look guide dictates the position of the eye controller, which determines the point where the eye will be directed. It would be convenient to set the direction of the gaze for both eyes at once. For that, I'll create a common controller. This will be the Control01 component. I'll create it as the child component of the head as well. I'll position it approximately in the same place where the eyes look guide is positioned and rename the component to eyes look. Then I'll add the parents to the IK reference array field. Let the eyes follow the common controller. So I'll add the local component to this list. And also, optionally, let the eyes be able to follow the head. So I'll add the neckC0 head object to this list. Now I'll specify this eye common controller in the IK reference array for the eye component, so that its controller follows the transformation of the common controller. And I'll probably add a tail. Despite the fact that it will be developed in Houdini, the secondary movements through the spring chain component will allow for a better perception of animation. I'll create it also as a child of the spine root. And perhaps I will set 4 sections. Add hosts for created components. Create the Control01 component as a child component of the head so that the attributes are always at hand. I'll rename it Head UI and position it above the head. Then, in the Component Settings tab, I'll disable All Keyable, since this component will only store attributes of others and I won't transform it in any way. I'll copy this component for another host that will be used for the components on the face, so as not to overload the head host with attributes. I'll shift it up a little and rename it Face UI. Now I'll copy it again to create the host for the tail. Now I will indicate the created UI components as host for the present components. Let's start with the neck. I'll open its properties and specify the host field as head UI C0 root. Now ear. I'll specify face UI C0 root. The same for the nose, the glasses, the eye, and the eye common controller, eyes look. Now I'll specify tail UI as the host for the tail component. For the spine, you can set a separate host, but as a host for it, I'll probably indicate the back common control. In a similar way, I'll create hosts for the limbs. I'll make them child components of the hooves and shift aside a little bit so that they are easy to reach. I'll name the first one Leg Front UI and specify it as a host for the shoulder, foot, and leg components. I'm repeating these steps for the back leg and specifying the created host for the foot and leg components. Now it's possible to build the rig to see how everything works. I'm opening the general settings of the guides, specifying the name. Let it be horse. And enable the Use Classic Channel Names option so that all attributes of all components are unique and not grouped, so that it's possible, for instance, to adjust the spring of the ears individually. I'll select the general group and click Build from Selection. I'll check how everything works. Hide the guides, disable the polygons in the viewport, and enable joints. Checking the body, the eye, the neck, the hosts, the space switch. Seems like everything is in order. The only thing I don't like is the behavior of the shoulder blade. It co-rotates with the chest. But we can fix it. I would also probably remove the roll controllers on the components of the foot. They are too bulky. I think in a horse, this kind of behavior is easier to animate via attributes. I'm deleting the rig. I'll enable the display of guides and click Settings of the component Foot Front. And in the Component Settings tab, I'll disable the Use Roll CTL. Now the same for the back foot. And I'm clicking the shoulder settings. I'll change the connector type to Orientations. This will allow for setting the inheritance of rotations of other objects, while the remainder transformations will be inherited based on the component hierarchy. Now in the Component Settings tab, in the IK Reference Array field, I'll indicate the components for inheritance of rotations of the shoulder blade. I need it to rotate along with the body. So I'll add the body common controller, body, and also we'll add spine just in case. I'll mirror the symmetrical components using the duplicate symmetry option. It works only for one component at a time, so I'll need to set it one by one. Feet, the ear, and the eye. I'll rebuild the rig. I'll check how the shoulder blades work. We can see that their rotation depends on the body, not on the spine. Great. Now we can proceed with setting the look of the controllers. I'll skip this stage because I've covered it in detail in the lesson on the anthropomorphic character rig Dick. And in fact, this can be skipped and you can work with the default shape of controllers. But personally, I consider it to be too bulky, so I'll change the look of the controllers anyway, for them to be more ergonomic. In the end, I got this design. I've changed the shape so that the controller is easy to distinguish and select. I've enlarged the size of the main controllers and reduced the size of secondary ones. Now I'll bind the body to the rig joints. I'll select all the joints first, then the body, and change the skin. I'll select the Bind Skin Options command, set Bind To selected joints, and Bind Method to Heat Map. Also, I highly recommend to disable the Remove Unused Influences option, so that after the weight computing, Maya doesn't remove joints with weights of 0 from the skin geometry. In many cases, it merely makes the skin editing more complicated. I'll check how the neck works. We can see that it is rotating in a weird way. Here, the rotation distribution doesn't work properly in the neck component. So I'll delete the rig. In such cases, it is required to turn the neck blade, which dictates the original orientation of the objects in some components. I'll select it and change the blade roll offset parameter to 180. We can see that the blade is now turned to the opposite side. I'll generate the rig again. Bind the body. And as we see now, the neck behaves properly. I'm grouping the rig objects, moving all the geometry into the Geometry GRP, and moving the guides, the rig, and the geometry group in the common group. Horse RI. Now I'll bind the rest of the body parts of the horse to the rig joints via the skin cluster too. I'm changing the bind method parameter in the bind skin options to the default closest distance option. Since the heat map option doesn't always work properly, and also for the weights to be calculated faster. The very weight settings probably won't be revealed here, so as not to repeat myself, everything here is the same as in the lesson with the Dick character. Keep in mind that the mane, the tail, and the bracelet for the neck will be synchronized in Houdini, so the setup and their deformation can be paid little attention to here. They are included into the animation rig just for better perception of form of the character in animation. Don't forget about the Delta Mush deformer. It should be added for the body to save time for the weight setup and get deformations of better quality. I recommend that you do some basic skinning so that the rig allows to more or less adequately change the character's posture. After that, we can proceed to the animation.